Okay guys, I am going to show you how to derive the quadratic formula. You never will have to derive the quadratic formula yourself. I'm never going to ask you to do that. All you need to know by the end of this is what the quadratic formula is and how to use it. Okay, so let's go. So basically, what we want to do is we're trying to find the x-intercepts of this thing called y equals ax squared plus bx plus c. So we know that the general rule to find the x-intercepts is we have to set y to 0. So that's easy enough. Okay, we're going to set y to 0. And then what we have to do is find the x values that make this true. Well, I can see that there are two values of x here, so I can't just bring everything over to one side and divide. I need a different way. And that special way is something we already know how to do. It's called completing the square. So let's start. We know that when we complete the square, the first thing we want to do is take a out of the x terms, right? So what I'm going to do is take a out of the x term, and I'm not going to spend time justifying this to you. If you guys need to pause the video and convince yourself that b over a is what happens when I factor a out of b, you can pause the video and figure that out if you need some time. What I'm going to do now is what I've always done when completing the square. I take my middle term, I divide it by 2, I square it, and I add and subtract that term, okay, within my bracket. Okay. So guys, this is the completing the square step. Now remember, the next thing we do when we complete the square is we have to move this term to the outside, and when I do that, I have to remember to multiply by whatever's in front of the bracket here. So I need to multiply by a. So guys, I've just applied the power of 2 to my bracket and multiplied it by a. So let's simplify. Okay, so if you don't believe me again, here you can expand this to see if I have factored properly. In my next step, what I want to do is find a common denominator here. And now I'm just going to bring these two terms to the other side, because ultimately the goal is to get x by itself, so I'm going to start moving these other two terms to the other side. Okay, so what's next? Next, we are going to put the left-hand side over the same denominator. And then what I notice is I can actually factor out an a from these two terms. So what I'm going to do is factor out an a. We can see that these two values cancel out. All right, so for the next step, if you remember, and if we had numbers in this question instead of A's and B's and C's, you would know that the next step, the most important step, or one of the most important steps about getting x by itself is when I take the square root of both sides, I have to remember the plus minus. Okay, this is really key. So let's rewrite this equation up here. Okay, so we have one last step. We have to bring the b over 2a to the other side. Okay, so technically we're done, but actually we can simplify this a little bit further by recognizing or remembering that if I take the square root of a quotient, I can actually simplify it by taking the square root of the numerator and denominator separately. So we know that this guy is the same as 2a. So what that means is I can actually join the denominator. I can join these two terms by writing them over the same denominator, which is 2a. Okay, and there we have it, guys. This is the quadratic formula. And what you'll notice, actually, is that there are two answers here for x, right? So I actually have two different values for x. Two different x values that will make the function ax squared plus bx plus c equal to 0. So the first one is going to be negative b plus b squared minus 4ac over 2a. And the second x-intercept is going to be negative b minus b squared minus 4ac over 2a. So let's just review what we did here. Essentially, the most important thing is understanding the concept of what we were actually solving. So we are actually solving for the x-intercepts, okay, the x-intercepts of a parabola. And the way we did that is we set y to 0, okay, and then we completed the square and solved for x. So essentially, this guy here, okay, this guy is the solution set to this equation right here, where we've set this equal to 0, where we've set the quadratic equal to 0. Okay, so these two are connected. And this is what we call down here, this is what we call the quadratic formula. Okay, guys, so I'm going to stop right there for part 1, and then in part 2, we're just going to do a bunch of examples using the quadratic formula.